Hello from Safonovo. This is a podcast Pigeon of Peace where we do discuss some skills of troubleshooters. Watch, listen, and check the description below for the details. Let's talk about system engineering and let's start with the definition.
System engineering is interdisciplinary approach to design, to integrate, to manage complex large-scale systems from the design period to their retirement. It utilizes system thinking to ensure that device component would be appropriate and work together efficiently so to satisfy customers' needs and would be новые прорывные, new and breakthrough. Breakthrough, yes.
And usually, I think you already mentioned that because, yes, we can start with the fancy technologies, like all of the nice frameworks or tools or anything like that. But you mentioned the customer. So whether this system engineering should be happening with the customer in mind, and I do believe it could be completely different for different units, companies, and even the cultures. But when we think about it, like, should we start like with, I would say, ideal end result and maybe ideal user problem that we want to solve, or usually it's like fell apart. We just know like what exactly is the problem, and it's like very mathematical if we just try to be more descriptive, and then we just go and figure out the solution.
Yes, you're quite right. We should use a holistic cross-functional method that focus on the big picture rather than just individual components. So we should oversees the entire process, including conceptual design, then projecting, development, testing, operation, and I was already told retirement. For example, if you create a car and then you should predict how people would repair, I know how to say, flashlight, fare.
Flashlights, yes.
Flashlights. And it was a joke several years ago. It was a Porsche problem. They showed how easy to detach the flashlight from the car. And suddenly on a huge amount of streets or in different capitals, you will see a blind Porsches without their flashlights, and each cost like 2.5 from 2.5 to 4.5 thousand euros. So from one point, it's quite easy to detach, but from other point, it's quite easy to steal. Or, for example, vice versa. Let's talk about Chinese cars, and sometimes to change the filter, you should disassemble half of the car, and sometimes people will say, okay, what's the problem? Just to change filter in Audi or BMW, it's cost like 20 euros, but we should pay like 200 euros just to change the same filter in a much cheaper car.
Well, since you already mentioned like risks, I would say like if we're looking into probably the balance like versus the value, maybe even the costs that we're going to put into this value and the risks that we're also ready to accept, or we have a mitigation plan or some sort of like a risk kit or whatever. So how this balancing usually may work, and I do understand it could be like a plenty of reasons, even the political ones, giving that, like we want to deliver something, but maybe it will broke in, I don't know, like after 10 minutes of usage. So how the evaluating framework looks like?
Okay, first you should develop requirements, translate user needs into technical specification. Second, you should do logical or physical analysis, create architecture and design solution by yourself. Third, you should think about integration and testing, assembling some system and verify them part by part. For example, if you design program or if you design something like mechanism, you will understand that there are subsystems which could be tested individually, and you should think, okay, could I make it more reliable, or could I make it working smooth, or should it be quite light in the weight? On the MBA skill, I provide the example which I was astonished. I was in Germany and I learned from McKinsey that there was a problem. When Japanese brought to Germany their alarm clocks, Germans would wouldn't buy them. And when McKinsey was asked what's the problem, it's quite accurate alarm clocks, and they are very resource friendly. They just contain small chip and batteries and almost nothing like other stuff. But suddenly, McKinsey guys, which came to the stores, they found that Germans would not look into the alarm clock, but they somehow weighed it in the hand. Who knows why? And then McKinsey told, okay, you should put huge magneto in each alarm clock to make them looks heavy. If it is heavy, it would be worth to buy, because German think, okay, why you should use this very light mechanism? If it is light, it would be not reliable.
Well, yeah, and sometimes even when the building stuff, there's could be also many ways to achieve the what we want to do. So let's say like in this example, it was more like a post-production where certain modification came in place. But if you look into the production stage as well, because at certain point of time we may have like a lack of resources, or maybe like there is a technology that we want to use is not fragile or not accessible. So how the looking at the different opportunities, looking at the different options looks like, and again, like what is the decision-making framework in order to decide like which one place or which one of path you want to take in order to like build the entire system or entire product.
Okay, you should about key concept, and key concept is system thinking. You should look at the whole system and its iterations, not just part. For example, if you want to create a new washing machine, you should think how people do this job. So you should observe, and you should think, okay, people work with this machine because they like this way, or because this is need. For example, there are two kind of washing machine. I was working with huge producer of these home appliances, and you should load the machine from up or from the side. And a lot of people will say, okay, it's handy to load from upside, but in this case, you should not put something on this machine. So everything from this machine to the ceiling is just empty. So no, if you have a small house, you should use side loading. It was first. Second, okay, where should be buttons be placed? And engineers were saying, yes, for sure, on the main body. I don't know how to say corpus, main body or something
Body,
like
yeah.
on the body, because in this case, everything would be very stable. But German pros, they were saying, no, we want buttons on the door. But if you will put them on the door, it would cost like 30 to 50 at this period of time, Deutschmarks higher. And women will say, okay, it's worth it. So sometimes engineer would say, okay, it's quite easier to create. But people will say, I don't want too easy. I want to be more comfortable. The same, for example, when you just produce just small piece of lumberjack tools like X. In our culture, we could put just stick and this X on it. But if you will think how people work, sometimes you will understand that this X, I don't know how to say, handle should be curved in a very special way. And maybe it would be even replaceable, because you sometimes will use it to make something very light, or sometimes you will use two hands to cut the tree.
Well, you actually mentioned another part of it, which is like a quality assurance, and I do believe it could be like a different ways of, like how we can test and validate the thing, and maybe even discover like a new qualities. So maybe in the simple words, like how we should approach to looking at how we look into the quality of the item that we are about to produce or about to prototype.
Quality is quite a difficult thing to measure, because, for example, if we will talk about price, price has a lot of different steps, like 1 penny, 1 cent, one kopeyka. But if you will go to the quality, how many measures it has? Like 5 to like 10? How many? People will say, okay, it's quite quality, it's quite not quality. But for example, you will say about one thing, it is quality because heavy, and other will say, okay, it's not quality because it's heavy. So the same feature could be measured in different ways. So people who develop systems, they think in another way. Okay, if we will reduce something, will it give us the greater value for the goods? If not, system engineering is not worth to change. And there is also one principle: if it is working, do not touch it.
Well, and if we look into something that's already working and people like it, so how system engineering could help to actually see what could be improved and maybe even make a go or no go decision for certain models?
It's quite easy. When I do some science project with our pupils, I always say, okay, it's quite easy to develop, for example, macros or software or some idea, even formulas in Excel or maybe some forms in Access, but you should use it at least 1,000 times. And you know how it goes. Okay, if person will start to work with something again and again, it will say, okay, I should make a shortcut. I could create button. I could create special regime. I could automate something. And for example, 80% of the system engineering will go prior you're starting to implement something into the life. But 20% would be like a polishing. If you will use it very often, you will find what to improve.
And I guess we reviewed all of the aspect of the system engineering, how it could be helpful for you. Stay in peace.